Hi, boys and girls. It's good to see you again. It's been a few days, and now we're going to be adding and subtracting mixed numbers. But first, we have to review renaming. And this is an important concept for fourth grade, so I want you to take your time and let's understand this really carefully, okay? Let's review how we changed an improper fraction into a mixed number. Remember, we used the dividing line as a dividing line. And we took the numerator 13 divided by 6. And we know 6 times 2 is 12, so I know it goes in 2 times, but there's 1 left over, and we don't mess with the denominator. Now let me show you in picture form that that's really true. Let's do the 2 and 1/6 first. If I color in 2 whole squares, I don't have a magic Promethean board or what we called a smart board like Mr. Cameron does, so you'll have to bear with me. And 1/6 would be this much. Look at that. 2 and 1/6, right? 2 wholes and 1/6. Okay? It's also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 6. They're our equivalent. We just rename them. Just like a boy's name might be William. Well, in certain circumstances, he may be called Billy or Willie or Bill. Sometimes we need to use different forms of the same number. Let's look at this one down here now, 13 thirds. Well, let's divide it in our heads first. 3 goes into 13 4 times. I know that because 4 times 3 is 12, with 1/3 left over. Again, I made some boxes for you, and I divided them up into thirds. This time, let's count 13 of them, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I've got to use 1 from here. There's 13 thirds, or 4 and 1/3. See? Okay. Then we learned how to do the opposite. We started with a mixed number and turned it into an improper fraction. How we did this, well, let me do it in picture form first. If I have 5 and 1/2 circles, okay, I'm going to fill in 1 circle, 2 circles, 3 circles, 4 circles, 5 circles. Notice they're all divided into half. They're not perfect, so please bear with me. And 1 more half. See, I'd have how many halves all total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 halves. So we've just, in picture form, changed 5 and 1/2 into 11 halves. See that? Let's do one more. 2 and 3/8 now. I divided these circles into eighths. Let's color in the 2 and 3/8 first. Here's the whole circle. Then another whole circle. And we know 1 and 1 makes 2. Then I have to color in 3 of these. 1 little part, 2 little part, 3 little part, okay? That's 2 wholes and 3/8 of another circle. Now let's count up all the eighths because they're divided into, hopefully you'll see, they're 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 eighths. We just renamed that. Sometimes we have to use the improper fraction form. Sometimes we use the mixed number form, but we need to know how to do both ways. Now, you don't want to draw pictures for the rest of your life, so let's do these 4 in our head. 11 fourths. Well, improper. Let's use the dividing line. How many 4s are in 11? Well, I know 4 times 2 is 8, so I'm going to say 2 times 4 is 8, 9, 10, 11. 3 left over. So 11 fourths is really 2 and 3/4. Okay, let's do this one, 9 halves. Okay, improper dividing line, 2 goes into 9. The denominator into the numerator goes in 4 times, because 4 times 2 is 8, and 1 left over. So the improper fraction, 9 halves, is 4 and 1/2. Now let's draw a dividing line here and change the mixed number back to an improper fraction. We learned that all we have to do is take the bottom number, the denominator, 9 times 4 is 36, and add the top. 36 plus 2 is 38 over 9. And we've got the improper fraction, 6 and 1/12. Well, 12 times 6, if you've been doing extra math, you might know this. 72 plus 1 is 3 over 12, okay? Now, I'm going to take this down and we're going to apply this to what we're doing today. And what we're doing today is adding and subtracting, okay, mixed numbers and using renaming in them, okay? Today, our denominators are all going to be the same, so that's not going to be a problem. Like in 6 4/5 and 3 3/5, we're going to add the numerators because the denominators are the same. 4 plus 3 is 7 over 5, and 6 plus 3 is 9. But when you look on that, do you see something wrong with that? That 7/5 is improper. So let's work on that first. Just as we did in the previous page, let's use our dividing line. How many 5s are in 7? 1. And how many left over? 2 over 5. Don't mess with that denominator. But don't forget the whole number 9. It's got to be added to the 1 2/5, and it gives us a grand total of 10 2/5. See that? Okay, let's try this one. 4 3/8 and 1 5/8. Our denominators are the same. I'm good to go. 5 plus 3 is 8 over 8. Don't mess with the denominator. 4 plus 1 is 5. Now, what do we do in this case? Something looks wrong there, doesn't it? It's not done. It's not simplified yet. Because we know 8/8, 7/7, 6/6, 5/5. That's a whole in itself, isn't it? And 5 and a whole would equal 6. Now let's look at this one. 4 6/9 plus 3 5/9. Add up the fractions first. The denominators are the same. You always got to check for that. 6 and 5 is 11 over, don't mess with the denominator, 9. 4 plus 3 is 7. Uh-oh, we've got that case again when we've got an improper fraction. Let's take care of that improper fraction first. 9 goes into 11 one time with 2 left over. So 1 2 9s. But don't forget to add in the whole number. So the final answer here would be 8 2 9s. Okay? Now, subtraction's okay as long as the bigger fraction or mixed number is on top. In this case, it is. 7 3/4 minus 2 1/4 we can subtract with no problem. 3, take away 1 is 2, over, don't mess with the denominator, 4, and 7 minus 2 is 5, okay? Something's still kind of wrong with that. It's not done yet, is it? 2/4 we know from a previous lesson has to be reduced to 5. Don't forget to bring the 5 over, and I divide top and bottom by 2 because they're both even. 2 divided by 2 is 1, 4 divided by 2 is 2. Okay, no problem? Now, you notice I have this section in red because this is where the trouble comes in. What happens if the mixed number on top is smaller than the mixed number on the bottom? Uh-oh. Well, what would you do in regular numbers? You would borrow, right? Well, we do the same thing with mixed numbers, except we call it renaming. We're going to borrow, and the only place we can borrow from is this 5, right? So I'm going to take 1 whole from that 5, which leaves me with the 4. And that 1 whole, I'm going to turn into a fraction. A 1 whole in a fraction is what? 3 over 3, 3/3. 3/3 then plus the 1/3 I already had leaves me now, and I'm going to put this up here, with 4/3. Now, let me show you this in picture form. I tried to do this ahead of time for you. And just to prove to you they're the same. 5 and 1/3, 5 wholes, okay? 5 whole circles and 1/3 of another. And 4 and 3/3 is the same thing. 4, and then 3/3 is 3/3 plus 1 more third. They occupy the same amount of space on these circles. 16/3, no matter how you look at it, is 16/3. That's just a side note. Okay, now we can subtract. 4 minus 2 is 2/3. 4 minus 3 is 1. There's your answer. Now let's look at this one. This one's kind of cool. What if there's no fraction to subtract from? You can't just drop down to 3/4. A lot of kids try to do that. You have to have something to borrow from. Okay, where am I going to get that something? The only place I can get it from is the 7. If I borrow a whole from the 7, I end up with 6, right? Now, what am I dealing with? I'm dealing in fourths. So I want to use the fractional 4 over 4 as my whole to borrow from. So this becomes 4 over 4. You see that? 6 and 4/4 is the same thing as 7 all by itself. Now I can subtract. 4 minus 3 is 1/4. 6 minus 1 is 5. Can't reduce either of those, so we're done. Wow, that was a lot of work, wasn't it? Now think about that for a while, ponder on it. If you have any questions, ask Mr. Cameron through Google Classroom. If I need to do any further explaining for you, I'll be happy to. Next time I see you, we'll be adding and subtracting mixed numbers with unlike denominators. Okay? Have a wonderful rest of the day. Hope to see you soon. Bye-bye now.